How does factoring relate to determining whether expressions are equivalent? Think about this question during the lesson. Kiana is painting an ocean mural on a rectangular wall. To start, she painted the wall blue. She used 3 cans of paint, each of which covered X square meters, and a different sized can that covered 12 square meters. What are possible length and height dimensions of Kiana's mural? The expression 3x plus 12 represents the area of the mural. One way to solve this problem is with an area model. You can use an area model to represent the area of the mural, 3 times x plus 12. The first part of the area model represents the area covered by the 3 cans of paint. The second part represents the 12 square meters the large can of paint covered. Now we can look for possible dimensions of the wall being painted. There's 3 cans times x, the number of square meters each can covered. The other can covered 12 square meters. We can think of that as 3 times 4. So one possible set of dimensions of the mural could be x plus 4 meters long and 3 meters tall. How can you use algebra tiles to represent the expression? You can also solve this problem by using a common factor and the distributive property to factor the expression 3 times x plus 12. What is the greatest common factor of the 2 terms in this expression?
Select your answer.
The greatest common factor of 3 times x and 12 is 3. So we can rewrite each term as 3 times something. Then we can apply the distributive property. This expression, 3 times the quantity x plus 4, is equivalent to the original one. The factored expression represents the area of the mural as a product of 2 factors. So, another possible set of dimensions of the mural could be 3 meters long and x plus 4 meters tall.
Click on each expression to see its factored form.
Write an expression for the length of a pool with an area of 9/2 times x plus 18 meters and a width of 4 1/2 meters.
The blue area is going to be represented by x, and then the green area is this unknown number. So let's write out this equation. They want us to use distributive property, so the blank space here. Oh my goodness. This will be 9/2, and then on the outside, and they put x on the inside, and so 9/2 is going to be the greatest common factor on the outside. So 9.5 times what will give me 18. Because it is a fraction, you can use your calculator, but I'm going to show you mathematically or arithmetic to solve it. So we have 9 halves times what is 18. So we're going to do the inverse, which is divide. So we're going to divide by 9 halves. So make 18. I didn't mean to do that. Make it a fraction, and then we're going to do keep, change, reciprocal. Keep 18 over 1, change division to multiplication. Reciprocal of 9 halves is 2 over 9. I like to simplify first when multiplying fractions. So 9 and 8 actually have a greatest common factor of 9. So 9 divided by 9 is 1. 18 divided by 9 is 2. When you multiply straight across, you get 4 over 1, which is the same as 4. So this answer here would be 4. So the length of the pool is 4 meters. I'm sorry, x plus 4 meters, and that's x plus 4 because we're adding the blue tile to the green tile, and that green tile we just found the value of, so that's why the equation here is x plus the 4 to get that total length of the pool.
Rodrigo and Jordan each use an area model to represent and factor the expression -2 1/2 times x minus 8 1/3. Who factored the expression correctly?
Rodrigo has this part as 2 1/2, and negative x are factors of 2 1/2 and x. The green part represents 2 1/2, and -3 1/3 are factors and of -8 1/3 x, which is there. Then they wrote it out as 2 1/2 times the negative x minus 3 1/3, and it's minus because that is a negative. And then that equals -2 1/2 times x minus 8 1/3. And then Jordan has -2 1/2, and x are factors of -2 1/2 x. Then you have for Jordan's green part, -2 1/2 and 3 1/3 are factors of -8 1/3 times x. And so they pulled out the -2 1/2 plus parentheses x plus 3 1/3, and that's equal to -2 1/2 times x minus 1/3. And we look at each one, and they are equivalent expressions. So both Rodrigo and Jordan have represented the expressions correctly. Show 2 different ways to represent the expression. So just like in the previous example with Jordan and Rodrigo, we need to show 2 ways. So one way of representing this expression is to pull out the greatest common factor. So I'm going to try pulling out this first number here, which is -1/3. So I'm going to pull out 1/3, and I am not going to take out the negative because I'm going to keep it in the parentheses. So what's left to go inside the parentheses is my negative and my x. Then it's minus 17. I'm sorry, not 17. I'm sorry. It's going to be minus just 17, not 17 over 3. And I'll show you on this side why. 17 over 3 divided by 1/3, because remember, you say to yourself 1/3 times what will give me 17 over 3. So I'm gonna divide the two. We do keep change reciprocal, keep change reciprocal, and then I like to simplify first. So 3 and 3, I know greatest common factors. 3 divided by 3 is 1, so they both become 1. And then you have 17 over 1, which is the same as 17. So that's where that 17 came from. Another way would be now to put on the outside negative 1/3. Keep the x, and then this will be a plus 17. And we don't have to do the math again because we already did it, but we had to change the minus to a plus because we took out the negative, and a negative times a positive equals a negative. So that's why we had to change it to a plus, because if we kept it a minus, that would then not be equivalent to the original expression.
Are the expressions x times the quantity of -4 and 8/10 plus 6 and 4/10 times y and x times the quantity -3 and 8/10 minus 2 and 2/10 times y plus 8 and 6/10 times y minus x equivalent?
Expand the expression x to the quantity of -4 and 8/10 plus 6 and 4/10 times y by using the distributive property. So they pull the x and multiply it by each of those quantities, and you get -4 and 8/10 times x plus 6 and 4/10 times x and y. B, you expand the expression x to the quantity of -3 and 8/10 minus 2 and 2/10 times y plus 8 and 6/10 times y minus x by using the distributive property and combining like terms. So they used distributive property first and pulled out the x and multiplied times each of those quantities. After multiplying that by each of the quantities here, now they have to combine the like terms, and so -3 and 8/10 times x and the minus x here are like terms. So when you combine them, remember, in front of a variable is always an invisible 1 if it does not already have a number in front of it. So -3 and 8/10 plus the -1 will give us -4 and 8/10 times x plus 6 and 4/10 times x times y. And the question is, are they equivalent? And the answer here would be yes, they are equivalent because they are the same.
Are the expressions y times the quantity 2 and 1/8 times x minus 13 and 1/2 minus 2 1/4 times y, and y times the quantity 2 1/8 times x plus 15 3/4 equivalent?
We have to follow the same steps of the example and expand the expression. So let's look at the first one. And we're going to expand by using the distributive property. So we have y times the first mixed number, and that will give us 2 1/8 times x. Make that a little better. Times x times y minus now y times 13.5, and we'll get 13 1/2 times y. So that's our first expression. Then we have the second one. We have to expand. Oh, I'm sorry. Almost forgot about the minus 2 1/4 y. Okay, so now we're done with that expression as far as expanding it. Then we have to combine like terms. So we have this one and this one as like terms. So we're going to combine 13.5 and the 2 1/4. So we're adding them together. So once again, you may use a calculator, but I'm going to show you the arithmetic. So we have 13.5 and 2 1/4. They are both negative. And so when we're adding fractions or mixed numbers, we have to first make them improper fractions. So I'm going to make them improper, and we're going to get 13 times 2 plus 1. So 13 times 2 is 26, plus 1 is 27 over 2. And then negative 2 times 4 is 8 plus 1 is 9. So we have 9 over 4. Then both of these fractions must have the same denominator. So now we are going to change the 27 over 2 to reflect 4 as a denominator. So I'm going to multiply by 2. So now I have 4 as a denominator, and 27 times 2 is going to give me 54. And then we have 9/4. Now we can just simply add, going straight across. 54 plus 9 will give me 63. And then we can't leave it as an improper fraction. So we're going to take the 4, divide it into the 63. 4 goes into 6 once. We get, subtract that, get 2. We have 3. 4 goes into 23 5 times. That's 20. That's going to be 3. And so now we have here, after combining now these like terms, these two, we combine. Now it's going to be 15 and 3 over 4. And that's going to be negative because we have that minus there. And then just put back on our 2 1/8 times x times y. So that will be the first expression expanded. And now we have to do the same to the second expression. So we're going to do the second one now. Okay, so we have, again, use the distributive property. Y times 2 1/8 x is going to give us y, 2 1/8 times x times y plus now y times 15 3/4. That's going to give me 15 3/4 times y. Now this one is done. We don't have any like terms to combine. Now we just have to compare the two, and at first glance it looks like they are equivalent, but if you look closely, this matches, right? And this matches, but what does not match is that y. So because that y added to that, that's a coefficient. Because that coefficient does not match the other one, because it doesn't even have a coefficient, it is not equivalent. And that's it.